I think this is a chapter, according to the textbook, this is a chapter 4. Okay. Functions are major modularities of the current coding schemes and also past. Past means decades ago. In recent days, we were talking more about object orientation, but even we have object orientation, we have a methods. Method is very similar to the functions. So when you say here function, then it is a current and the past, the coding fashions. The functions are useful because if we have a long list of codings, then we can make we can separate a few of the code segment, and those code segments may be somehow modular modules. So that module may be called or invoked by another module. So those modules are handy to organize your coding list. So modularity is one of the major principles of codings. So rather than having long list of sequential execution, you may be able to make multiple modules, and then the modules among themselves are communicating each other. So modularity is the essential principles. Some decades ago, when I first started and learning coding, the modularity at that time was the first concept that we tried to learn. Okay, so if you do not follow these modularity principles, then I think no one wants to read your codings. If we have a module-based coding list, then each module may be able to be reused. So reusability is another principle of the coding technologies. What that means is that we define a function. There's a small module. That function may be able to be invoked not only one time, but many other times. You don't need, if it is a sequential coding, then you have to rewrite those functions. Rather than function calls, you have to execute sequentially. In that case, it is not reusable, right? So by defining one time of a function, you may be able to use it multiple times. So function definition and function invocations, those are the technique that we learn very seriously. So functions are useful. Like many other features, if there are pros and cons. If something is useful, then at the same time, there may be some risk, right? So functions are useful. At the same time, they may be vulnerable. A function may be able to contain malicious code. So small segments of a malicious code may be able to be embedded in a function. we will be able to see the example. Or entire function may be malicious. So malicious code itself. So functions are malicious in this case, right? Maybe entire coding list in function, or maybe small segment of the function may be malicious. Functions are vulnerable not only because function itself malicious, but also when we invoke a function, then we may not call it carefully. Okay, those things will be discussed in this chapter. Particularly, the functions are more dangerous if any malicious function is defined to call a system function, like execute, exec, or evaluation, eval. Those two functions are typical functions that we will be able to look at. There are maybe others. If you are talking about client and server issue, then there may be some secure shell execution. So secure shell, there may be multiple modules available, but if you want to attack or you are attacked by some function, then those functions may contain something like this on their coding list, or server process of the codings that may be again another issue. Today we'll look at particularly exec and eval, two functions. Exec function, execution functions takes objects and some of the variables. So what it does is that executing object, this is a code using global or local variables. Evaluation, executing one expression under the given global or local variables. This is the expression, this is a code, execute a code. So this will be another executable objects. Executable object can be called for execution. That is what it is. Eval is expression may be evaluated. So we can consider the following code. Let's say this is okay here. This is a function access. Let's assume one maybe this. We need to import operating systems. Therefore, this X, some of the exec functions may be call the system functions, operating system functions. And there is a os.system. This will do some of the operating system command taken. So os.system takes as parameter command line functions. So it starts PDF files, it starts Notepad, it starts Cipher, it starts to start some program. Okay, so we use this. If you see some of the command line. Now I'm working on the Windows systems. Then if we do here start Notepad, for example, then Notepad will be started. That is started in another terminals. Okay, this is the start. But if we do this is something that you can work here. Start and Notepad and sample.txt. Start txt, then that is executed, right? And then we have some Notepad. Here is a new something like this. Okay, this is passed. And you can save in save. If I simply close this, then it may not be saved, right? Save, no, don't save. Something like this. And also we can do Cipher. Cipher has by the way, if you want to encrypt, there is a remember the computer world had been suffered from one of cyber attack, which is called ransomware attack, right? So some program comes in your system and encrypt the files and folders in your systems. So if you see here, Cipher function list the files or folders, and it has some mark here. U means the encryption is not allowed. Encryption is not allowed. Okay, there's a particularly that ones. So I want to bring up the file browser like this. This is a file browser, right? So currently we are in users.jun. So it is something like here, then users in jun. So Anaconda 3, that is Anaconda 3, and the contacts, something here, right? So those are the files, and we have the file sample. So we have sample.txt here, right? So anything here cannot be encrypted. If you want to encrypt it, because there is a the function that we can practice, right? If we want to make a malicious code, sort of ransomware, then using Cipher, there is a E for encryption. If you do that, then there is an error, Anaconda 3 error, because this machine is disabled for file encryption, blah, 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 right? All of this. And then log 2, this machine is disabled for the file encryption because I tried to do encrypt, and then there is some log files created and doing this, right? This is something for in response to or to protect the ransomware attack. the Microsoft tried to make some solutions which is embedded in the Windows 11. This is the way that I really hate Microsoft. It's not really technologies, right? It disables all enables rather than a real protection or preventions. This is something it's not really technical approach. This is a very dummy approach. Anyway, so they disabled me to do. Then what should we do if you want to do cipher? Okay, cipher E, and then I have a sample.txt file. So that cipher and sample.txt, then there will be an error, right? Error, this machine is disabled for file encryption and 0 file within one directory. The laptop that I am currently using, this is Windows 11. This is owned by Mercy College. If it is not owned by Mercy College, and even if you have a Windows 11 at home, if you want to encrypt it practice this code, then here is the way that you can do. If you want to encrypt by executing some of the code, because inside that code there is an exact function called. Within that, there's an os.system function takes the command cipher/e for encryption, and then particular files. If you distribute this kind of the hidden and unknown functions, then if somebody execute this, then that file may be encrypted, right? If it is a system files, then a system is encrypted. Therefore, computer is not going to work. So that is usually the way that simply we can encrypt someone's systems. But anyway, to test this successfully, right now my computer is okay. This is something you could do, but mine impossible. Let me tell you why mine is not possible. If you make it right click on any file, any folder that you want to encrypt, because Windows 11 disabled it, but you could do that. And then there is this is something about sample.txt file, text. And if I want to, click on the advanced button here, then by default compression and encrypt attributes are not clicked, which means it's not allowed. Compression is not allowed. Encryption is not allowed. But if I want to do encrypt it and OK, then and apply, it's not going to work. If I want to do encrypt this file only, OK, then there is an error, right? It's not allowed. Encryption is not allowed. But anyway, if it is allowed, then you can do away. And then you can do same thing. I want to push this away. Okay. You can practice this. Instead of W, you can do E. And then there is another option, /W and colon. If you have /W and colon, and then followed by device. Device could be one specific the storage systems. On Windows, it'll be the C drive, E drive, F drive. On Mac, it could be mounted to that Linux operating systems. What this W would do is this is something that you can do also silently behind user function execution. So user does not know if this works. By the way, what happens here is that this is somehow a hidden function, okay? And then this is a user's code. User wants to do input functions. Enter your name, then it says welcome, and then do something. Meanwhile, we execute this, knowingly or unknowingly. If it's unknowingly, then eval, and then there is a function is evaluated, which is access open and close parentheses. This access open and close parentheses is nothing but this, right? So this is something hidden. This is something that you may know. Okay. So this access function sits behind this function call and do some cipher. Okay. Cipher could do encryption or decryption. This cipher W works, but it takes so long because I do not want to do this. What it does is that let's say sample, if sample is a directory or maybe a file, and these things, let's say if you are a hacker, you are caught by FBI, and FBI, no, not that scenario. Okay, someone who may not know in detail in your organizations. So they, if some technicians are dummy, then they may be able to look at your system and search it through all the files installed or available on your system, right? If you have some, let's say, bad malicious code, so temporarily you want to delete it. So hide it. You delete it. Something deleted it. If you use some of the cheap program, or if you can do some coding a little bit better, then you can restore, right? Restoration of deleted files is not really hard at all. What this cipher /W means, if you want to, let's say this is the functions. If you are a really intelligent and powerful system, I mean, IT professional, so if you want to maintain all the employees' laptop cleanly, in clean way, so that even if something deleted temporarily, remotely, if you want to remove something already deleted permanently, right? Then you can use this. Start cipher /W : if there is a temp directory, usually some malicious program comes in your system. If you delete it, then it may be in temp directory or maybe somewhere, right? So, or trash can, right? Trash can, it is there. Even if you delete something from trash can, still it is there, right? But if you want to permanently delete it, then you can use this. Remove data from data from available unused disk space on the entire volume. If this option is chosen, all other options are ignored. The directory specified can be anywhere in the local volume. If it is the amount of points or points to a directory in another volume, the data on that volume is permanently removed. That's what it is, right? You can make so many such things. Kind of a vulnerabilities. Somehow something white vulnerabilities, something maybe red vulnerabilities. But anyway, this is some example. This example can be done on Mac if you are Mac user, because this system is cold, right? The Windows system is not the same as the Mac OS systems. So if you see here this code, this is the same, right? But in the access function, OpenOS and OS .system, and inside, rather than start, we need to use open, right? Open cipher and open -E, then you can bring up. Notepad is not available on the Mac OS. Instead, it has another text editor, right? So that will be popped up. Okay. So why don't we this is somehow that we can practice. This is let's say this is the malicious code. Okay, functions. This is nothing but functions, and this is something that I know. So this is a trusted call. So enter your name and welcome, and then change directory and then eval access. But when you do eval access, you may be able to simply say, hey, I may open, oh, this is the Mac OS. Audio. This is Windows. Okay. So we can, this guy, this trust call, assume that's a notepad. So this guy think, oh, by doing this, then notepad will be opened so that I want to work on that. So before it is, of course, it does open notepad. Before it open notepad, it does some cipher, encrypt some of the files, malicious code, right? Like ransomware. So when I call this, then that it runs enter your name, then I can say John and enter, then open my files. So internally, this guy does not know whether this kind of the ransomware activated, and simply continue to work. Hey, now I am able to work and do something, right? In this way. this is kind of the function vulnerabilities, function call vulnerabilities. So save, come back here. So this is another example. I want you to somehow take a look at this. It's the same example, same idea. Let me explain this a little bit, and then we can continue to work. This guy somehow activates access. And when it comes to here access, then some of the hexacode is executed like this. This is hexacode, right? And then start notepad. And then JPEG file is running so that it runs. It emulate the JPEG files like this. Files, yeah. File name is hex.txt. This is a file name. This could be possible, right? Like that we did. This actually somehow the Python code that open the file, given F file, which is the field here. So what is field? Field is something that this guy receives. So that is express. This guy says enter JPEG file name in full path expression, then it goes to run like this. Curious. Let's see. Double click at. This code. And this is and that is this is the function that we can see. So if you run this, enter, oops, running, enter file name. This is not. No, this is the above program sitting above. So we need this. JPEG files are fully express the JPEG files. If we have JPEG somewhere, then we can test this. Picture, camera roll. No. JPEG files, maybe somewhere in my JPEG files. FJ1 oh, this is my photo. Maybe. That is a size. That's what it is. Oh, this is not. This is mine. But anyway, before we use this, so you can say copy and paste here. Then you can do app jun icon, jy icon, app jy com.jpg, extension jpg. Is it case or you have it now? Not quite sure. Oh, hexa.txt file is not possible. Okay. Do you want to create a new file? Yes. Hexa.txt. And then, oh yeah, that file came up here, right? This is the file that you can see. If I click this, then this is the file. Segue 3, segue 3. So what it does here, same way. Simply, this guy think, oh, Notepad starts. And then inside here, this, I don't think we need this, right? Because it calls this access, and inside this access, there is a JPEG render. So we don't need this. Actually, we don't need this. We simply run this program. This is because I didn't close this. And then I need to close this. And I still have, because it is called twice. So one time here, by calling this, it is called, and another call here. But anyway, that works that way. This is kind of the size of the files. So we know the functions may be vulnerable. That's because the function code itself a malicious code segment, or the way that we call a function may be carelessly called. So what should we do? How can we handle the functions? So there are two ways of handling. White box approach and black box approach. White box approach, then this function is already known. Okay, this is my function, and I'm calling this. Okay, so my function that I know, right? Anyway, this is a white box. But if I know when I call others, if I can see that also, so that if I can handle some of the mechanisms, if I want to implement something there, some of the prevention or detection mechanisms, then I can handle it, right? That is a white box. On the other hand, even if I call this access, this function is not known because this is black box, right? If it's a black box, then I need to handle it differently. The way that I can protect or detect, it should be should be, I mean, a different approach needs to be taken. So what should we do? If we know white box, the function that I call is known, then I need to put here some exception handler. Exception handler is one of the coding techniques that we can do, right? If it is Python language, but another language has more powerful the features available, then we can use others. For example, exception handling or escape handling. Escape handling is available on Swift, the language. Swift is the language for iPhone apps development. But anyway, so we can develop, and of course, the exceptions for this kind of the malicious code is not known, right? So you have to develop your own exception, which is user-defined exception needs to be developed. So you need to develop user-defined exceptions, and you need to raise that exception if there is some small issues. So modification this so that this function itself may be well protected. Of course, meanwhile, your function, this is your function. So you can do some of the exception handlings, raise some of the user-defined exceptions so that you can get clean function calls and function definitions. That'll be fine, right? However, if there is a black box exception, then what should you do? You cannot do anything from here. Only something that you could do is, before you execute that, before you call this function, after you call that function, you need to check. If there is some issue, then you need to raise exception, user-defined exceptions. And then you need to handle that exceptions. And exception handling has been discussed, right? In the textbook, there are a few other examples available, but I want you to read it. If you are capable of doing that, you could do so. Some of the things are unavailable right now because it is a client and server architecture required. Then the Windows systems is not good for impossible to do the server functions. But anyway, so this is